Welcome back to the EXP Group's discussion of CIMA paper P1. Today we want to spend a little bit of time to look at the mix and yield variance calculations. Now, mix and yield, these arise from a deeper analysis or breakdown of the materials usage variance that we described last time. Conceptually, the mix part of this mix and yield variance is looking at the result of changing the combination of the two materials that are put together in order to produce an output. So the mix, think of the mix as being changes in proportions of the two materials, whereas the yield variance is looking at the output that's achieved as a result of the total amount of inputs that are put into the process regardless of their combination. So we're separating out now the impacts of the mix, the proportion of the two ingredients that go into the product, and the yield. Yield is a term normally applied to output achieved in agriculture, for example. So we're looking here at the relationship between outputs and inputs. The best way to appreciate the mix and yield is to look at a numerical example. Now let's take a simple example. Suppose we have the following inputs that are required, or the standard ingredients for producing one unit of output. Suppose we have material X, and we need 5 kilograms of X at $8 per kilogram. That will give us on a unit basis $40 of material X used in 1 unit of output. Material Y, we need to have 10 kilograms, and that costs us $3 per kilogram. Therefore, we will have total value of $30 of material Y in our product, and therefore we have total of $70 of the two materials, the two ingredients X and Y. Let's look at the how we would look at a mix variance based on the following story. So for a given period of operation, we actually produce 12 units of output. This is actual. And in doing so, we use 50 kilograms of X and 145 kilograms of Y. So that's our actual situation. Now, the mix variance that results from the above is as follows. What we want to compare and calculate is the standard mix of the actual inputs should have been a ratio of 1 to 2. This is X to Y. We can see that here. For every kilogram of X, we would have expected 2 kilograms of Y. And this standard mix we would apply to the total kilograms that were used in producing 12 units of output. This is 195 kilograms that were actually used, actual input in producing the 12 units. And therefore, if we break this down according to the 1 to 2 ratio, we would have expected a standard mix of 65 kilograms of X and 130 kilograms of Y. You can see here that we are preserving the standard mix. Now, the actual mix was, and here we take the 195 and we just follow the actual ingredients that were put in. We had an actual usage of 50 kilograms of X and 145 kilograms of Y. So of the 195 total kilograms, the combination of X and Y varies from the standard. Okay, this means that we have generated a mix variance, and we can see that the mix variance here is 15 kilograms favorable. In other words, we used less of X, and on Y we can see that the variance is also 15 kilograms, but it's adverse in the case of Y. This is actually useful at this moment to realize the mixed variance when we're talking about the units difference. They're going to be equal to each other, but in possibly different directions. So now we can see that they kind of offset each other. However, from a value point of view, the cost in dollars of the variances now are going to be different. X costs $8 and Y costs $3, and therefore our variance, when expressed in monetary terms, is going to vary in the following way. We have $120 favorable variance with regard to X and $45 adverse variance with regard to ingredient Y. So our total mix variance is going to be the sum of these two, or $75 favorable. Now the interpretation here is that basically we've substituted more of the cheaper material Y for X, and therefore we have an overall favorable variance relating to the mix. Okay, now let's move ahead using the same basic data and think about this in terms of the yield variance. Now, from the standpoint of yield, the analysis, we're going to keep the standard mix of X to Y being 1 to 2. We're going to keep that constant, and we're going to look at now a comparison of inputs and outputs. In other words, what we're saying is that the yield that's achieved, 12 units, should have used how many kilograms? If you go back to the initial standard at the top of this, we can see that we would expect to use 15 kilograms total per unit, and therefore 12 units should use or consume 180 kilograms of materials in the proportion of 1 to 2. Now, the actual inputs that were used was a total of 195 kilograms, and this is the root, gets to the root of the variance now as seen from a yield point of view. Now we're going to express the 195 kilograms in terms of X and Y, preserving the same mix, which gives us standard mix of 65 and 130. Now we can calculate the yield variances here. We can see it's 5 kilograms adverse for X and 10 kilograms also adverse for Y. If we convert these into monetary costs, then we can see that the yield variance is going to be equal to $40 plus $30, both of which are adverse. So we will have a total adverse yield variance of $70. Finally, we can summarize that the total that the sum of the mix and yield variances, in this case, the mix variance being favorable $75, plus the yield variance being adverse $70, will give us a total materials usage variance equal to $5, and that will be favorable. Thank you.